takes a lot of effort to talk in front of a big group. And this is Andrea's first time. So let's give him a round of applause. And there you go.
Can I start? Okay. Well, good morning, and thanks for being here. This is my first time DEF CON. It's a big pleasure to be here. My name is Andrea Marcelli, and today the talk is looking for the perfect signature and automatic YARA rule generation algorithm in the AI era. I am a PhD student at Politecnico Torino in Italy. I study machine learning, semi-supervised modeling, and optimization problems. But I'm also a security researcher at ISPASEC Sistemas, where I work on new techniques for large-scale Android malware detection. Today we will talk about the signature generation problem, about the algorithm that I have developed and the tool that I have developed. Then we go through a quick demo and some results of the algorithm. So let's now start talking about the signature generation problem. And what is a malware signature? A malware signature is a unique pattern that indicates the presence of malicious code. And since the problem is that since malware evolves over time, new signature should be generated very frequently. And historically, there are two types of signatures. There are syntactic signatures and semantic signatures. Syntactic signatures are those based on textual strings and on binary sequences extracted from the application. And this is also the industrial standard type of signatures, and where most of the existing research focuses on. Instead, today, we will talk about semantic signatures, which, according to some recent literature, could lead to a better detection, and thus provide an abstraction of the program behavior. So in today's talk, we'll talk about Android malware and automatic signature generation, but all the concepts are very generic and should be applied and could be applied to other targets too. So which are the motivations behind the work? Well, first of all, we want to reduce the malware exposure time. Second, writing a malware signature is a very repetitive task. And keep in mind that with from 20 to 50,000 new applications received every day, manual analysis is not an option. Then we have a goal, which is 100% recall and very high precision requirements. In other words, we want to lower both false positives and false negatives. And lastly, in the end, it's all about saving a lot of resources and time, because writing signatures manually, it's very time-consuming and expensive. Today, we will generate signatures using the YARA language. YARA has been defined by Victor Alvarez, his creator, as YARA is to files what's north is to network traffic. And the advantage of YARA is that YARA is fast, and it's also the standard type of languages that is used in the antivirus industry, so it's very spread. And YARA natively supports syntactic signatures, but it also supports semantic signatures through custom modules, so you can write your own modules. This is an example of YARA rule. There are three main sections, although the most important one is the condition, that is where the logic of the rule is placed, and also where the semantic attributes of the signature can be added. Now let's go through the algorithm. The algorithm for the automatic malware signature generation is placed within a pipeline that is very common to many antivirus antivirus software houses. And the idea is that there is a submission of new APKs every day, and those APKs are analyzed through machine learning techniques, mostly unsupervised techniques, in order to automatically infer new malware families, that is, the clusters. And in the end, for each malware family, you want to generate a signature, and this is where my algorithm comes in place. And in order to generate a signature, you need to start from some attributes, some features extracted from the application through the application analysis, both statically and dynamically. And just to have a graphical representation, each feature could be a small square within the gray grids that you can see in the slides. And could be, for example, an URL, could be a permission, an intent filter, or everything else. And it's very, very important that the analysis is performed very carefully, because through the analysis, we extract the attributes, and having good attributes is the key to have a good signature too. So the idea behind the algorithm is very simple. We have two applications. We have a set of attributes for each applications. Probably some attributes will be of the same type and will be actually the same between the two applications. In this case, we have some orange and some green attributes which are the same. And actually, we can generate signatures by combining those attributes. Although the reality is much more complex, and as you can see, in most of the cases, you cannot find a unique pattern which is in common to all the samples of the same malware family. And so the problem of generating a signature is the problem to find the attribute subsets that cover the entire malware family, all the samples of the entire malware family. And if you think about it, it's a problem that is very similar to a very well-known problem in the literature, which is the set coverage problem. Actually, this is a variant of the set coverage problem, which unfortunately is very hard to solve because it's an NP-complete problem. But since we are not interested in a global optimal solution, we just need a local optimal solution, I have developed a dynamic greedy algorithm to solve the problem, and actually automatically generating a signature. So as you can see, generating a signature is not such a big issue. But the main challenge is to evaluate a signature. So in order to better understand this process, I will introduce a couple of formulas. First of all is the DNF, the disjunctive normal form, where a set of clauses are in logic OR, and each clause is made by a set of literals which are in logic AND. And a literal is one of the attributes that we have extracted before through the analysis. So if we reduce each signature to a DNF, we can actually weight each clause. And in that way, we can say that the weight of a signature is actually the lowest among its clauses. And this weighting process is the base of the evaluation process of a signature, because if a signature has a very high weight, it means it's too specific. It will not be able to generalize and will actually produce a lot of false negatives. Instead, if it's too generic, it will generate a lot of unwanted detections, that is, a lot of false positives. So we want to generate a signature which stays between two thresholds, Tmin and Tmax, and that's where the optimal signatures are. So as you can understand, the key of the weighting process is to actually assign a good value to the attributes. And the value to the attributes is very tied to the value of the two thresholds, Tmin and Tmax. And actually, I want the entire process to be automated, and I didn't want to rely on the knowledge of the expert analyst. I just wanted to make it automated. And one of the possible solutions is to start from the repository of YARA rules. There are a lot of public repositories of YARA rules that you can parse them and reduce to the disjunctive normal form. Then it becomes a linear problem that you can solve by means of a linear programming algorithm, like the simplex algorithm. And in the end, you are able to satisfy the 95% of your rule set in order to have a weight which is between the two thresholds. Why 95%? Well, because some rule sets are so specific to a type of malware family that it's not possible to really extract some useful knowledge for them. Well, when I actually implemented this algorithm, I ran into a new problem. That is, the signature were too specific, too many attributes. The weight was so high, it was actually impossible to use them. So, in order to create a better signature, we have to remove some attributes. How to remove them? I have developed two strategies. One very simple, which is the basic optimizer, which simply randomly throws away some attributes. And then the other is the Evo optimizer. And why we need the evolutionary algorithm to optimize the signature? Well, there are some non-written rules about how to generate a good signature. And those rules can be placed within an algorithm, a genetic algorithm, that actually find the best combination of them to generate the best signature. And the good thing about all of them is that they are very fast. One less than 1 minute, the other about 5 minutes. So it's scalable. So I actually implemented the entire procedure that I have described into an algorithm, which is called interprogram, which is called YARA. YARA is an acronym that stands for yet another YARA rule generator. And if you know Spanish, you will probably know that Yaya in Spanish means grandmother. And the goal of YARA is to create, is to start from a set of application reports, which means start from the result of the analysis of several applications and generate for them a set of YARA rules. YARA includes a lot of functionalities, and for sure, the most important one are the algorithms to generate a rule. There are two variants. There is the clot and the greedy. The clot is an enhanced greedy, because the problem with the greedy is that probably you will generate rules which are not homogeneous in the number of samples that are covered. Instead, the clot tries to generate a rule with all the same coverage in order to create better rules. Then we have two optimizers, the basic and the Evo one, and some heuristics, because in the signature generation, it's all about heuristics. For example, we are very interested in including some URL if those are malicious, so there are some heuristics to understand if a URL is malicious. There are some heuristics to throw away some attributes, so performing some kind of filtering at the beginning. And the software package also includes the YARA rule parser for attribute weight optimizations. So if you have your own set of YARA rules, you can actually apply this program and find out which values satisfy the rules starting from your set. Then it also supports the false positive exclusion. And although a false positive match is something very rare with our automatic generated signature, we want to include this option in the rule generation. So in case of unwanted detection, you just include that detection into the process of generating a signature, and the signature will not match that false positive anymore. Everything is was written in Python 3, so very easy to use and customize. And finally, as you may understand, this is just a plugin within a much bigger infrastructure, because you need an infrastructure to actually analyze the application and an infrastructure to test the rules that you have generated. And that's the reason why YARA has been written to directly work with Kudos. Kudos is the open antivirus from ISPOSEC, and it's free and open to everyone. And it works with Android applications, Android malware. So the great news about YARA is that it's free, it's on GitHub, so any improvement is really welcome. Now I'll go through a short demo. Okay, in this case, I'm using YARA to generate a rule using the clot algorithm for the SkyGo3 family, malware family. And as you can see, I gave in input some hashes of known applications that belong to this family. And what the tool actually is doing now is just downloading the report of the application analysis from the internet. So I said it's generic, and it is, because if you change this part, that is, if you feed into YARA another type of report, it's all about changing which attributes are selected, and then everything can be optimized. It's not tied to this type of report only. And the rule that is generated, and everything is super fast because I didn't speed up anything. And the rule that is generated is a valid YARA rule. So you can actually use this rule in your system, be only aware that probably you will need some custom modules in YARA to use it, according to the type of the attributes that you use. In our case, we are using AndroGuard and Cuckoo, which are modules that are available in Kudos, but probably if you will use it on your own platform, you will have to add them. And let's just go through the rule. This rule has 17 literals, which means 17 attributes, with a score of 484, which is a quite high score, and it's above the threshold. The minimum threshold is set to 400. It has a coverage of 8/8, which means that all the samples that I gave in input are covered, because in this case the family was very tight. If the family is loosely defined, doesn't matter. Simply find more rules. And that's all for the demo. Now let's go back to the result. I wanted to compare the efficacy, the effectiveness of the automatically generated rules with the human written rules. So I started from some of the available ones, and I tried to recreate an automatic version starting from some sample that were originally detected. Well, actually, I did some tests on a 1.5 million dataset of Android applications collected through 2017. And what came out is that all the automatically generated signature improved the number of detection, ranging from the 8% to the 131%, with an average of 65%. So it's a huge improvement, and all of that without not even generating a false positive. So in order to conclude, I developed a set of algorithms to automatically generate YARA rules. I did it in the context of Android and using YARA language, but as I said, everything can be easily ported to other targets and other languages. And what comes out is that automatically generated rules perform better than human-generated ones. Then, one interesting fact is that there are several ways in which the expert knowledge can be included into the YARA rule generation. For example, there are the heuristics. There are the way in which the attribute value is set. And there is also the optimization phase. So actually, a malware expert can really increase the quality of the automatically generated rules. And finally, all the approach is very scalable, because generating a rule for 100 apps, it takes less than 5 minutes. And if it grows to 1,000 apps, it takes around 30 minutes, less than 1 hour. So it's a lot, but it's orders of magnitude less compared to the manual work. We are working on a new version of YayaGen, which will target Windows executable. It's called YayaGen P. We are still working on that. We are still testing it, but preliminary results are very great. So I will keep you posted if I have any news. And that's all. Thanks a lot for attending the talk. And if you have any question, I would really appreciate to talk with you off the stage.